Is it better to have many false negatives or too many false positive? So uh, I would say it is application dependent. Let's say you have a model that performs disease diagnosis. Does a given patient have disease X or not? It is better to have false positive here. It is okay to falsely assert that a patient has a disease and then later realize that the decision was wrong, maybe after more tests, some preliminary medications. However, a false negative here means that someone who had a disease was not provided proper treatment, which could be fatal. On other hand, consider a model that shortlists resume of a job interview at a company, assuming you have more promising candidates than the number of positions you want to fill. A false negative amount to rejecting a good candidate, which is not so much of an issue given that you will get other such candidates. However, a false positive means you shortlist someone who is not good enough, which will waste company's resource in the interview process. Next question is how many footballs can you fit in a Tata Nano? So I guess a typical football will be of this size, like 11 inches. Then we can do pi r square for 4 by 3 pi r cube to find the volume of a football, and then we can find the typical volume which is available in a Tata Nano car, uh, subtracting the seat volume, and then we can multiply the football size into number is equal to the volume of a Tata Nano car. So basically, typically we can go in other way, like 4 to 5 people can sit into that, and in a Tata Nano. One person volume will be around if we do it like, but again there are so many open space which will be left. So the previous approach will be the good one to find how many footballs can you fit in a Tata Nano. Then the next question is, what is your favorite machine learning algorithm and why? So my favorite is random forest because it works on most of the works on most of the uh, data, and which which is basically a collection of decision trees. The great thing about random forest is that they almost always outperform decision tree in terms of accuracy. Next question is, what is type 1 and type 2 error? So a type 1 error is a incorrect rejection of a true null hypothesis, while a type 2 error is incorrectly retaining a false null hypothesis. More simply stated, type 1 error is to falsely infer the existence of something that is not there, while type 2 error is to falsely infer the absence of something that is actually there.